All right, starting lesson 5.2, once again, working with identities. Get familiar with all identities on the yellow sheet. All right, example 1, verify the identity. Okay, to verify the identity, you look at the more complicated looking side. That would be the left side in this case. And you need to simplify it and obtain what you have on the right side. Okay? Now, you always pick the more complicated side. Now, you never move from one side to the other. All right? Never move anything from one side to the other. Just simplify whatever you have on one side, and you're working with the complicated looking side. All right, so what do we have here? Here we have sine squared theta plus cosine squared theta. Well, if you know your identities, you know that that's equal to 1. So using your Pythagorean identity, you can replace the numerator with 1. On the bottom, we have cosine squared secant squared theta. Okay. Next step, I'm going to divide this into two fractions, just split it. It's the same thing. Okay. But now I can replace 1 over secant squared by applying the reciprocal identity. So I have 1 over cosine squared theta. Okay, and 1 over secant squared theta is the same thing as cosine squared theta. All right, now for your reciprocal identity, it says 1 over secant equals cosine. Okay, now the same thing applies with squares because you can square both sides and you get what we have here. 1 over secant squared theta is equal to cosine squared theta. Now the cosines cancel out and we're left with 1. All right, so I went from the left side, I manipulated it, all right, kept applying my identities, and eventually I ended up with the right side. Mission accomplished. Okay, verify the identity. Once again, choose the more complicated looking side. That'll be the left side. Okay, all right, it seems like there's a lot going on here. It looks pretty complex, but we just need to find a common denominator because we're adding two fractions. So I'm going to multiply the left and right side. Left side here by, or I shouldn't say the left and right side, I should say the left fraction. Okay, and the right fraction here by, actually this one's plus. And the right one by 1 minus cosine beta. Okay, so I end up with what on top? 1 plus cosine beta plus 1 minus cosine beta. On the bottom, what's my common denominator? Since these binomials are conjugates of one another, all you have to do is multiply the first terms and then multiply the last terms. Okay, and you could have FOILed it if you wanted. That's just a couple extra steps, but you're still going to end up with the same denominator. All right, now we simplify the top. These cancel out, and I'm left with 2 over 1 minus cosine squared beta. Okay. All right, we have a 1, we have a cosine squared beta. You should be looking at your Pythagorean identities at this point. And 1 minus cosine squared beta is the same thing as sine squared beta. All right, applying the Pythagorean identity, or a variation of it. All right, and at this point, we could get rid of the fraction by doing this. You don't have to do this step, but sometimes it helps students see things easier by doing this. All right, so 1 over sine squared beta, that's the same thing as cosecant squared beta, just applying the reciprocal identity. All right, so I have no fractions now in the expression, and I made the left side just like the right. All right, I manipulate it to become the right side. Mission accomplished, done. All right, example 3, once again, choose the more complicated looking side. That'll be the left side. Okay, well, we could easily simplify this part by applying a Pythagorean identity. That's equivalent to tangent squared x. Okay, what about this piece here? All right, if you look at your Pythagorean identities, you have the one with sine and cosine, and there are variations of it, but they don't quite match up with this one. Okay, so let's see what's going on here. Here's the standard Pythagorean identity with sine and cosine. This is just a little side note. This has nothing to do with the problem. I'm just focusing on the identity here. Okay. Then I have cosine squared x is equal to 1 minus sine squared x. Okay. And now I'm trying to get this to look like this. So I need a negative 1 and I need a positive sign. So I'll multiply by negative 1 on both sides. Okay. And I get negative cosine squared x is equal to negative 1 plus sine squared x. Okay. Or I could rearrange these two terms. So negative cosine squared x is equal to sine squared x minus 1. All right, so I'm going to replace this with negative cosine squared x. Alrighty. And now, what's the next thing we could do? Well, how can you relate tangent squared to cosine squared? All right, well, tangent, we could apply the quotient identity, and we'll get sine squared x over cosine squared x times negative cosine squared x. All right, so cancel those out there, and I'm just left with, don't forget this negative. After all that work, you don't want to forget that negative. Negative sine squared x. And mission accomplished. We got what we wanted on the right side. All right, so in example 4, verify the identity. Which side's more complicated? You could say the right, you could say the left. I'm going to work with the left. Okay. It doesn't really matter which side you start with. All right, just so long as you obtain the other side, that means you verified the identity. I'm going to start with the left side. And let's see, how can I relate cosecant to sine? Well, cosecant is the same thing as 1 over sine of x. All right, that's a start. I'll write this as a fraction, and I need a common denominator. So often students get confused about what to do at the very beginning. It helps just to start applying some identities, and then sometimes just by applying one identity, you begin to see where the next step leads into. All right, so here I have 1 minus sine. Then I have sine of x on the bottom. Okay. What next? Well, right away, Pythagorean identity should stand out from that. So I'm going to replace that with cosine squared x. And I have it over sine x. Okay, we're almost there. See, I have a cosine here now. I need a cotangent, though. How are you going to get cotangent? Well, let's think about the quotient identity. Cotangent is equal to cosine over sine. Well, I could break off a cosine from this fraction. Okay, and that's what I have now. And I can replace this with cotangent using the quotient identity. All right, and now I have the same thing, right? Because it doesn't matter how you multiply two values, but I'll just reorder it anyways. All right, mission accomplished, done. All right, same deal in example 5, verify the identity. Start with a more complicated looking side. I would say that's the fraction. Okay, so here I'm going to multiply by the conjugate. And the reason for doing that is because it introduces a square into the problem. And when you have a square, you can apply the Pythagorean identity, hopefully. So now I have sine of beta times 1 plus cosine squared beta. Oh, not squared, oops. Beta. And over, since they're conjugates, I just multiply the first terms and the last terms. Or you could FOIL it and simplify. You still get the same thing. 1 minus cosine squared beta. Okay, what next? All right, now I can apply the Pythagorean identity here. Okay, and now I could cancel out one of the signs on the bottom with the one on top. So now I have 1 plus cosine beta over sine beta. Okay, we're almost there now. I'm going to break this fraction up into two fractions. Okay, and 1 over sine beta is the same thing as cosecant beta. And cotangent is the same thing as cosine over sine beta. All right, so for the first one, I applied the reciprocal identity. For the second one, I applied the quotient identity. All right, so now the right side, we manipulate it to look the same as the left side. Mission accomplished, done. For example 6, we're essentially verifying the identity, but they're telling you which piece to start with. So typically we would start with this because that looks more complicated. But we're starting with this because they told us to. All right, so what do you do here? Well, let's factor it, break it up, because here we have a tangent squared, so let's make this have a tangent squared. So I'll break it up into tangent squared x times tangent squared x. Okay, All right, well, let's see. Can we apply the Pythagorean identity to that? Yes, we can. We get secant squared x minus 1. All right, and then from there, you can distribute. Oops, yeah. And we end up with what we have on the right side. And we're done. It's as easy as that. So once again, when you get very familiar with the trig identities, doing these types of problems becomes very easy. And at first, it may be a little difficult to see how to start out the problem, but just start applying some identities. And once again, once you apply one identity, it takes you to the next step. And once you see that next step, you'll know where to go next. All right, if you have any questions, if you need any clarification, please make sure to ask. Begin the assignment at the bottom of the webpage.